Great. Thanks everybody for joining us today. So we're going to be talking today about the new revised CalAdapt. We are very excited to have launched a number of new features and new tools and a whole new look with CalAdapt, and we're really excited to be able to introduce this to all of you today. So with that, I do like to mention that CalAdapt is an effort that a lot of people have taken part in. So I always want to thank both our funders, the California Energy Commission, and also the Strategic Growth Council for supporting CalAdapt. Everything on CalAdapt is made possible by our very talented, hardworking web development team. I'm the person who talks about CalAdapt in presentations, but it's all thanks to the web development team that all the great work and tools that you see on the site are functioning. So I'm Nancy Thomas, and I'm the director of UC Berkeley's Geospatial Innovation Facility. And we also work very closely with a number of partners. Eagle Rock Analytics, Owen Doherty is our chief scientist. We work really closely with UC Berkeley's or UC's A&R program, IGIS. Andy Lyons is here with us today, and he'll be presenting some of his work. We also want to thank all of the researchers who provide the climate data that we show on CalAdapt. As a lot of people know, CalAdapt, we don't, our team doesn't really create the climate data. That's all information that was created by researchers throughout the state of California. So it's a big effort, and we're excited to have you here with us today. So I think most folks are pretty familiar with CalAdapt. Our goal is always to make this climate science data accessible and actionable for users. So we want to make data that's very complex, sometimes challenging to understand. Climate data sets are usually very large, sort of unwieldy to work with. So our role at CalAdapt is to make that data more useful for people. So we do that by presenting interactive charts and maps. For locally relevant climate information, users can enter their own boundaries and look at their own areas of interest. And then we always try to make it easily accessible by using plain English descriptions to describe this data. The data is all peer-reviewed, best available science, and our job is to make it easier for people to use this complex climate information. What we've been doing over the past several months is really listening to stakeholders and engaging with many users and potential users of CalAdapt to really understand how we can improve it to make it even more useful for people. So we've done quite a large effort on stakeholder engagement. We have an online survey which is collecting feedback and demographic information for our users that is still on the website. If you're interested in sharing your information and your thoughts on CalAdapt, feel free to participate in that survey. We've participated in many workshops and webinars over the past year or two. Of course, they're all remote over the past 2 years, but there's been much outreach in that type of work throughout the state. We try to reach different regions of the state to understand what user needs are. And we also have worked really closely with a wonderful graduate student, Lucy Andrews, who was a part of our team. She did over 36 hours of focused interviews with people trying to learn more about how CalAdapt is used and what we could do to improve the website. So we've really been gathering a lot of information from people on how they are using CalAdapt and how they would like to use it in the future. So some of that information includes, finding out how familiar folks are with data science. So a lot of our users are fairly familiar with climate science. Not a lot of expert users. One of the questions we ask in our online survey is how people hope to be able to use CalAdapt. And we learned that there's a lot of different ways that people are using the data from CalAdapt. There's a lot of interest in, exploring data through the charts and graphs on the website. There's also a lot of users who are downloading the climate data directly to use in their own platforms. So all of this is really helpful for us as we try to improve CalAdapt. The focused interviews that were done, again, we had over 36 hours of focused interviews. And those interviews are semi-structured. We ask key questions of participants and then sort of see where the interview goes and what information people are interested in sharing. Some of the general questions are, how do you use climate data? Where do you access it? What's missing for you in climate change adaptation work? And how can state and academic communities help support that climate adaptation work? So we reached many different organizations. A lot of the focus on these interviews were local planners and municipalities, as well as community-based organizations, natural resource managers, a wide range of users and potential users. We also tried to make sure that we had, again, a regional representation across the state. You'll see that we don't have as many folks from the Central Coast, so we're still interested in reaching out and hearing more, again, from users around the state on how they are interested in climate data usage. So from all of that information, we have gathered quite a bit of information about how folks want to use CalAdapt. A couple of the key things are that CalAdapt's support team and the fact that we're continually updating the website is really appreciated by users. So thanks again to our web developers and the support team for the great work that they do. People really appreciate the flexibility in CalAdapt, the fact that users can put their own parameters into many of the tools, and output download options. People like the way that the website looks. It's aesthetically appealing. One thing that we did hear from a lot of people is that CalAdapt serves a technical audience very well, but it can be difficult for new users and people who are less familiar with climate data. So that's something that we really have has informed all of the changes that we've made to the website. And that's what I'm going to be showing you today. So some of the key recommendations that came out of that stakeholder engagement is that we should be creating more help materials for people. A lot of people who are less familiar with climate science didn't understand some of the acronyms on the website. And a lot of people don't have necessarily the basic climate science that enable them to use some of the more complex tools on CalAdapt. So creating more help materials. There was a lot of interest in developing a more simplified tool so that people could access climate data without having to think about things like what GCM they might want to use or what time periods they should be looking at. So really a simplified tool that allows people to look at climate change data for a particular location without having to enter their own inputs. So to make it a simplified entryway. People are looking for a library of tool walkthroughs, blog posts, and videos to help learn more about the climate tools. People are also interested in connecting the climate change data to more mapping, spatially explicit maps of more demographic and socioeconomic conditions. But that's something that's a little bit that we haven't done so much on CalAdapt. There is the OPR Vulnerable Communities platform, which is being developed. And I think that platform is going to answer a lot of those types of questions. So we have taken all of this feedback and have refined CalAdapt and revamped it to really meet those user needs. So what I want to do is introduce you to some of those new looks and features that we have on the website. So you may have noticed we just launched the revamped CalAdapt this week. We're really excited about it. Thanks again to the developers for working so hard on making this possible. So this is our new homepage. We have made it a little bit easier. I don't know if you're familiar with the old homepage, but it had a bit more text description. we did some beta testing on different designs of the homepage, and people really liked this version where you can just quickly scan these different blocks of information, and you can click on them and get to the information that you're looking for. So this is just a really quick entryway into CalAdapt. If you're interested if you're new to CalAdapt, you can learn how to get started with some of our climate data. We really emphasize the local climate change snapshot tool, which I'll be talking about for a few moments. So it gives users a clean and easy way to enter CalAdapt and learn more about what's on the website. So excited about our new homepage. One of the main areas of new content that we've developed for the website is a whole new help section. So this is a new onboarding ramp for new and less technical users who aren't as familiar with climate change science and best practices for using the data. We have our Get Started section for those users. We've also added an FAQ section, so to provide answers from users that we hear regularly about CalAdapt. And we've also defined and explained more technical terms within our glossary section. So these are all under our help content, and I invite people to go to the website and start to explore. I'm going to quickly walk through some of these Get Started pages. This, again, is something we're really excited about to help build climate science literacy for potential users of the website. So you'll see, if you go to the Get Started page, you'll see that it's organized into these 5 sections. And users can go to any of the sections that they're interested in or jump around. And we'll go through each of the sections a little bit. So for the first section on climate change and climate data in California, we are really placing CalAdapt in the framework of California's 4th climate change assessment. The 4th assessment came out and includes many different data sets that were created for that 4th assessment, which are hosted on CalAdapt. So within this table, we note the different climate variables, the general trend in how those variables are changing, the confidence in those variables, and then the CalAdapt tools that you can use to explore those different variables. And this table is modified from a table that's in the 4th assessment key takeaways report. So again, we're really trying to place CalAdapt within the larger ecosystem of climate change information within the state. We also have a page on using climate data in adaptation planning, and we worked really closely with OPR and the Adaptation Clearinghouse on building this into CalAdapt. So we really want to help people who are trying to use CalAdapt for vulnerability assessment and adaptation planning. So we're really excited about linking more closely to the Adaptation Clearinghouse and other types of planning guides. This is an example of linking to the adaptation planning guide to, again, help people to understand sort of that next step of using the data from CalAdapt for a vulnerability assessment. So we're excited about having those links made much more clear within our Get Started pages. And another thing that we are really excited about is a new page on best practices for using climate projections. So again, something that we heard from a lot of stakeholders is that there's a lot of confusion about how you actually use the data that you can find on CalAdapt. So we go through many of the different recommendations from our chief scientist and from the state on how you best can use this information that's on CalAdapt. So again, I encourage everybody to take a look at that, and we're interested in your feedback on how useful this information is. So hopefully people get a chance to take a look at that. Another thing that we're excited about is these updated FAQs and glossary section. So again, we have a new glossary section, which is really trying to define all of the various terms that are used in CalAdapt so people can understand more easily what the data sets that we're looking at are and the different climate variables. And I'll show you how that's linked into our tools in just a few moments. Another thing that we are excited about, folks may have seen this already. We have a new tool called the Local Climate Change Snapshot tool. This one is actually a few months old now. We did a webinar on this back in March of this year. That webinar is on the CalAdapt website if you're interested in learning more about the Local Climate Change Snapshot tool. But this tool was built to be that easy to use, introductory and accessible tool for users who maybe are not interested in entering in their own thresholds, or they're selecting what GCMs they want to use. So it's really intended to support municipal adaptation planning, education, and advocacy. So it's a simplified tool. It simplifies the settings for parameters like the GCMs and the time intervals to quickly provide information for a local area. And within this tool, you can look at many different climate variables within your one chosen location. A couple of things that I want to point out about the tool is that it actually helps users to make sure they're following those best practices in using climate data. So the tool, this is a chart that is shown as you start exploring different climate variables. And I just want to point out a few things. The data that it's showing you is averaging over a 30-year time period. And that is one of the recommendations for best uses of climate data. So we're trying to make it really easy for people to follow best practices without having to think too hard about that, or to know too much about what those best practices are. This table also shows data for 3 time periods. Again, it defaults to these 3 time periods so that users don't have to think about entering in their own dates. There's a baseline period. This is the period that's used for California's 4th climate change assessment, the 1961 to 1990. We automatically default to a mid-century and an end-of-century time period. And you'll notice that within this table, we also include both a medium emission scenario, the RCP 4.5, and a high emission scenario, RCP 8.5, so that users can easily look at the difference between those 2 different scenarios. We also show data as a change from baseline and then also averages. One of the other things that we are interested in showing is the range of information. So this is actually looking at all of the 32 climate models that were downscaled for California, and we're averaging those models to present, sort of an easy number for users to focus on and enter into their reports. But we also include a range. The 30-year range is showing the range of all of those models. Because of course, we don't know what the future is going to hold. So we want to make sure that people understand that uncertainty in the different models and that range of data. And then we also make it very easy for people to extract this information. So as with all tools in CalAdapt, you can download the graphics, and you can also download the data into a spreadsheet that goes into making each of these charts. So it's always easy to access the data in CalAdapt. We also, in this local climate change snapshot tool, we also link directly to California's adaptation clearinghouse. Again, this is the ICARP site that has many different resources available for people who are looking at climate change in California. And the way that it works within the snapshot tool is it's actually already linking to resources that might be related to the climate variable that the user is interested in. So it's already pre-selected based on the climate variable that you're looking at. And again, we did hold a webinar on the local climate change snapshot tool. So if you're interested, you can find that on the CalAdapt website. One thing that I do want to point out, we were really excited in that webinar to be able to partner with Climate Resolve. Natalie Hernandez from Climate Resolve joined us in that webinar, and she was able to talk through and demonstrate how that snapshot tool can be used. That was specifically in the Affordable Housing and Sustainable Communities Program grant application. So we're hoping that as we develop more webinars, that we bring in more CalAdapt users to showcase how they're actually using the data on CalAdapt. So thanks to Natalie for doing that. So now I want to just show you quickly some of the new design that we are using for our climate tools on CalAdapt. What we have tried to do is standardize and streamline the user experience across all of the CalAdapt tools. Our tools have sort of been built ad hoc over the years as the Energy Commission has requested certain tools to be built. So this was a great opportunity for us to take the time to really standardize everything so that it's easier for new users to come to CalAdapt and understand each of the climate tools and how they work. So I'm just going to point out a few highlights from our new redesign. The first thing I want to showcase is that similar to the local climate change snapshot tool, we're giving this quick stats bar that defaults to those 3 time periods. So again, we're looking at the historical data, the baseline time period, and then we're looking at a mid-century projection and an end-of-century projection. And also similar to the snapshot tool, the quick stats gives you an average, a 30-year average value, and then also shows you the range over that period. And we're looking right here at the extreme heat tool. I think a lot of people are familiar with this tool. It's one of our most popular and frequently used tools in CalAdapt. The extreme heat tool is telling you how many days of heat above a certain threshold are projected for a specific location in the future. And within this tool, users can select what models they're interested in looking at. And whichever models you have selected are the ones that are shown in this quick stats bar. So it's an interactive feature. Another thing that we have really streamlined is our select location. So how users actually go about selecting the location that they're interested in. This is something that we heard was a bit confusing from our stakeholders. So we have tried to streamline that process, and I'll show you how to do that in a few minutes. But you can basically click on that change location, and you can select you can search for an area, and you can also select whether you want to use some sort of boundary layer to aggregate your data. For example, the county layer, census tracts, watersheds, places are cities. So those are frequently used for how people want to interact with the data and what information you're looking at. So again, that's standardized across all of the tools now. And then we've also standardized this, how users enter the information and select the climate variable that they're interested in. Different tools have different climate indicators. All of the tools have both of the medium and the high emission scenarios, so users can select which one they're interested in. This particular tool allows you to either use a default threshold or to enter your own threshold. And then again, you can also select which climate models you're interested in looking at. So all of our tools will have this, this type of interaction on the right side for users to select the information that they're interested. All of these different selections also have a little learn more button, and that actually goes directly to the glossary entry for those particular variables. And that's something that I'm really excited about, because again, what we're trying to do is really standardize the user experience across all of the tools and across the full website. So you can now click on those little learn more and find the information as it's shown in the glossary and in other pages on CalAdapt. And then just another thing I want to point out, on all of our CalAdapt tools, again, you can always download the data directly from the tool. And that includes either downloading the chart or downloading the data itself that goes into making the tool in a CSV file. So you can always download the data and make your own graphics if you're interested. You can bring that into Excel or some other other software package and do your own charting and graphing. So that's something that we always try to make possible on our CalAdapt tools. So again, we're excited about being able to standardize this experience. And then also our tools, we always have had links to the peer-reviewed research that is the data sources behind the tools. We also have now added in quick links to getting the actual full data set. So you can use our data download tool on CalAdapt, or you can access even more data on our data server. So we've tried to make that even easier within our new standardized tools. And of course, you can also link to the references, again, the peer-reviewed references for all of the data sources that are on CalAdapt. So with that, actually, I'd like to pause for just a moment and see if anyone has any questions or comments. Eric, I know you're looking at the chat. Is there anything that we should address together before I move on to the tool demo?
I think we're pretty clear on in the chat box.
Okay, great. And we'll have time at the end for any questions or comments anyone might have. So happy to do that. And now I'm just going to do a quick switch to showing you a live demo of one of our new tools that we're really excited about as well. So hang on while I do that. Great. So I'll actually show you. So on our home page, again, there's many different ways to get to our climate tools. I personally will go up to the toolbox. And then what we're going to look at right now is our new extreme weather tool. And you'll see that this is still in beta. This is something that we're really trying to get feedback from users on this tool. So please feel free, as it says in this note, the tool is still under development and we would love feedback from our users. So you can always email us at support@cal-adapt.org with any comments or questions. And this tool is quite different from the other tools that we have on CalAdapt. As you know, most of the tools we show on CalAdapt are looking at projected climate change information. This tool actually is allowing us to look at current information. So the way the tool is set up right now, it doesn't have any climate projections. It's really looking at historical past data and our current weather conditions. So again, a bit different from what we have in many of our other tools. Another thing that's a little bit different about this tool is that it's looking at weather station data. So it has location data, and I'll show you how to change that information on the map in just a second. So the data is looking at, it's built for users to ask the question, how extreme is the weather that we are having right now, or in the recent past? So the way this is done is by looking at historical weather conditions from 1991 to 2020. And it's looking at these historical conditions around a specific day. So the tool actually defaults to today. And it's looking at how has the weather been on today and a few days around plus or minus 10 days on either side of the date. What's the temperature been on average over these this time period, 1991 to 2020? So it's really allowing users to think about how extreme are the events that we're seeing right now. And the way that it's done is by plotting, this is a histogram of all of that observed data at a certain location for that baseline period. And then it's showing you what today's temperature, the tool right now is allowing you to look at maximum temperature, minimum temperature, and wind speed. So the tool is telling you what is that temperature today and how does that fit into the average temperatures that we've seen on this day over that time period. And I'm just going to show you quickly how I might change the location. So again, this is a station data set. So you'll see that there's points. So what we have is this information at each of these weather stations. You can always type in the area that you're looking for. So I could type in, I can't, Berkeley. Berkeley, California. And what it's going to do is show me the station that's closest to the location I typed in. So the station that is closest is actually the Oakland Airport. So I'm going to confirm. And now it's giving me my weather data at this Oakland Airport station. And again, what it's showing me is today's projected temperature. As a user, you can change the variables. Again, it's maximum temp, min, and maximum wind speed. And you can look at either the high or the low extremes. So you might be interested in whether today's temperature is particularly high, but you also might be interested in, whether it's really on the low end of this histogram. As a user, you can also change the day. Again, it defaults to today, but you might be interested in looking at something that, an event that occurred, a heat event that occurred in the summer. So you could change the date that you're looking at. And you can also change the threshold. So what it's doing is defaulting to today's temperature, but you as a user might want to explore whether, what is actually an extreme condition. So a few other cool things with this tool are that it is including NOAA data, both recent observations. So what this is showing us is what the, we're looking at maximum temperature right now. It's showing us what the actual temperature has been over the past 7 days. So that helps us to put our current weather in context. We can also show the 7-day forecast. So again, this tool is a little different than other tools that we have on CalAdapt because we really are starting to bring in this current observation data. So again, a little bit new for CalAdapt, but really fun to look at and explore. And the way that we're using the historical information, we're using something called, I'll go down to the about the tool. We're using extreme value theory to determine whether the temperatures that we're seeing right now are within a normal range. So are they really rare events or are they events that are common? And I can sort of, you can learn more about that, about the methodology used in this tool in that section. You can also look at different information on the tool itself to learn more about that extreme value theory. But so for example, today, the maximum temp at Oakland Airport is about 64 degrees. And you'll see that that is a common event. So our quick stats in this tool will tell us whether this is common or rare. And we can start to explore, like if we actually had a temperature today of 70, you'll see that that is actually a rare event, and you can actually see where it's placed on this histogram. So the weather that we're having today is pretty common, but if we had, for example, a much warmer day, that would be something that's more extreme. So this is really fun to play around with. This is a tool that was specifically built for the energy sector to really start looking at their information and think about whether, again, how extreme is the information and the weather that we're seeing today. So hopefully you'll explore this tool on your own, and please feel free to give us feedback at any time. As I mentioned, we are really looking for feedback on this tool, and you can always email us at support@caladapt.org. So with that, I am actually going to stop sharing my screen, and I'm going to invite our partner from IGIS, Andy Lyons. His team has also done a lot of great work on improving CalAdapt and making it more accessible for more users. So with that, I'm going to stop my share. And Andy, thanks again. Feel free to take it away.
All right, great. Are you hearing me okay?
Yes. And
okay.
I see your screen. Thank you.
Cool. Yeah. The lawnmower started outside. So hi, everybody. I'm Andy Lyons, and it's been a real fun to work with the CalAdapt team and as part of this project. And what I'm going to describe today are some software tools that myself and my colleague Shane Fryer have built, which I think the best way to think about these tools are as bridges between CalAdapt, and we just saw all of the nice interactive tools on the website, but also other tools such as programming environments, such as R and Python, as well as ArcGIS Pro. So I'm going to summarize that in a few minutes. Myself and Shane, we work for a group called IGIS. That's a unit within the UC Ag and Natural Resources Division. So we're partners with the CalAdapt and the Berkeley campus and other campuses, but we're very applied in our piece of the UC system. So if anyone's interested in more about this, I'd be happy to chat with you. As Nancy said, this is we are a small piece of a bigger project. So really grateful to the whole CalAdapt developers team, Brian and Shruti and Eric and Lucy. We couldn't have done this without them. And of course, we couldn't have done it without the support from Strategic Growth Council and the Energy Commission. So thanks to everybody for making this work. It's been a lot to work with. I don't have to go through this. We all know in this audience that CalAdapt is the go-to source for downscaled climate data. That's kind of the niche product that the CalAdapt portal has. And I think most people know also that it's not just California, it's all of California, but all of Nevada also, and good bits of the neighboring states. So all of this data is available through CalAdapt. And of course, all of this came from the fourth climate change assessment. So this isn't cherry-picked data from the literature. There are various committees that reviewed it and decided which ones were appropriate for California. Where that data actually live, though, they live on servers. There's one server on the Berkeley campus, but a lot of this stuff that you see on the website is coming from the cloud. And it's those data servers that are providing all of the data to the website. And they do that through an API, and APIs are open. And the good thing is that if you know how to work with the API, you can use that same language to get data into these other programming environments like R, Python, and ArcGIS Pro. That's been difficult until fairly recently. You had to know JSON parsing and network stuff. But now the stuff that Shane and I have done is create bridges to make that a lot easier. So I won't talk through all of this here, but I guess the summary, the message here on this slide is that there's different ways that you can get to the data. The website gets you everything, but these new tools that that we've been working on will make it easier to get to not everything, but the majority of the data you can now get into these programming environments. Why might you want to do this? Well, the short answer is because climate data are large data, and it can be a real fire hose of information. And the tools on the CalAdapt website are great examples of taking this large bits of data and presenting it in very digestible, user-friendly, intuitive ways that are also, working with the data responsibly and wisely. So in R or Python, you might want to have your different kinds of visualization. So maybe customize the graphs or the maps that you want to do, maybe for your report. A lot of times we're interested in the projections, but we're probably interested in feeding those climate projections into something else, right? We might really want to know how is this going to affect health? How is this going to affect wildlife distributions and stuff? So you may want to combine those results with other data, and these platforms are great for that. There's lots of other algorithms that are built in Python and R and ArcGIS. So you can use those tools once you get the data in there. You may want to build up your own model, or you might want to create a little decision support tool, a little bit similar to what you see on the CalAdapt website, but that's really tailored for your use case. Whether that's, how is it going to affect the growth rates of plants and animals in the future, or infrastructure load, or that kind of stuff. Okay. So CalAdapt Py is one of the two tools that we developed. This is a library for Python or module. And if you know Python, then you can load this into your Python environment and start using it in things like Jupyter Notebooks. ArcGIS Pro, which is a very popular GIS desktop software for making maps, it speaks Jupyter Notebooks natively, and it knows how to work with Python code. So one of the things Shane has built is a little toolbox that you can double click on it in ArcGIS Pro. This little menu opens up and you can select the data that you want to bring into ArcGIS Pro. You don't have to go to the website and download these ginormous raster files or CSV files. You can get it directly into Pro, and the files will be put into your project. And then from there, you can do all kinds of things with ArcGIS Pro. It's a very, very powerful package for working with spatial data and all kinds of visualizations. What we're looking at here is a three-dimensional voxel, which is like a space-time voxel. It's one of the ways that you can visualize spatiotemporal raster data. There's a link here that I will, let me put the link to the slide deck into the chat window. Ready to go there. Shane did a workshop on using his Python library just a couple weeks ago, and he's going to do another one in February. So check out that recording if you're interested in how to do this. The other package that we've developed is for R, the open source statistical programming language R. It's called CalAdapt R, and it's kind of similar. It's a classic API client. It gives you more, new functions that you can type into R, and that will allow you to get data into the R environment. And once you've done that, you can then use other packages from R to make plots, to do your analyses, to share the work that you're doing, all kinds of stuff. Okay, so R is a very, very powerful programming platform for data science in general. It's lots and lots of powerful stuff. I'll give a real quick example of what this looks like if you're curious what R code looks like. First of all, anyone who's worked with R, this should look a bit familiar. You load the package into your memory. When you use the package, you have to first create something called an API request object. And you can do that by stringing together a set of functions that collectively build up the pieces of your data request. What is the GCM that you want? What are the dates? What are the climate variables? So on and so forth. There's some other functions you can use to check your API request and make sure it's ready to go. You can plot it. You can even see what are the climate pixels that it's going to query. Then you can take that API request object, you can feed it into another function. It's going to download data on the fly, and then you get back the data as a table. And in this case, you can see the last column in this table are the temperature values. So if you've never worked with R, this might look weird and confusing, but if you're an R user or you're willing to learn R in a short course, this is something you can come up to speed with pretty quickly. Another reason people like R and they like working with R is because it's Shiny. So Shiny is another R package and allows anybody who knows a bit of R to create browser-based, user-friendly apps that will have R running in the background. So you still need to know R to build a Shiny app, but you don't need to know a lot of other web development stuff, which is hard stuff to do. So like JavaScript, HTML. So with this package, with this Shiny package, you can create fairly quickly these little browser-based decision support tools that would, someone doesn't need to know R, because R certainly has a learning curve, as do all command line languages. So I've got one loaded up here as an example. You can upload these to the websites. This one's running locally, but this is a web app that is designed to help tree crop growers determine, what variety of tree crop should they plant to be prepared for climate change in the coming decades. And it's very user-friendly. It's a website. You can click on the map to select your locations, or you can upload a farm. There's a few dials and levers. I won't go through all of this right now, but you can collect, what are your GCMs? What are the emission scenarios you want to look at? Likewise for your projected data. And then to do the analysis, you have to say, okay, well, how much chill? So chill is something that's important for tree crop growers. If the winter's not cold enough, the trees don't know when to bloom. That's the essence of it. Anyway, you pick all your options, you fetch the data. I've already done it a couple minutes ago. It only takes a couple minutes. And then it generates this little report. And then you can print this report. And it gives, I won't go through all the details here, but it will give you a number of charts that would help someone, who worked with trees, some information about to make a decision, right? So it takes a kind of complicated model and makes it really easy to work with. There's some other features for the R package specifically. If you are a researcher or you're doing something for the whole state, it does have some features to download lots of data. You can pump that into an SQLite database as it's coming down, so you don't have to repeat that. You can get rasters. It does have a copy of the CalAdapt data catalog. And there's some features, some functions to help you find the data. There's over 950 raster series in the CalAdapt API. So just finding the right layer is sometimes half the battle. And then it's got a bunch of convenience functions. So if you're interested, we do have some workshops coming up in February. There's also workshops that have been recorded. We've each done at least one workshop on these two tools. I've just wrote a blog post. And then both of these tools have their own websites where you can get lots of information. So I will stop there, and I'm happy to take any questions if people are interested.
Thank you, Andy. We might wait until the end for questions. We have a few more slides to go over, and then we're happy to open it up to questions after that. So if you have questions for Andy, hold on. You can also feel free to put things into the chat. We are trying to address questions that way. So with that, I'm going to just finish with a few more thoughts. Let me just set this back up. All right, so we also have some new data sets that we've added into CalAdapt. And thanks, Andy, for all of your work. It's been really useful for a lot of users. You know, we have a lot of users who are very familiar with GIS or with R, and being able to make it easier for those people to bring in the climate data that's on CalAdapt into their own workflows has been really helpful for a lot of people. So again, we're really expanding the user base for CalAdapt and making it easier for more people to use climate data. So thanks, Andy, for the great work that you have all done. I'm going to share a little bit of other exciting research. This is some new data that we have developed under CalAdapt. And I want to thank our partner, Owen Doherty from Eagle Rock Analytics. I'm presenting some of the research that he's been working on for this project. And hopefully I will speak about it intelligently. We really want to thank Owen for his great work. He is our chief scientist on CalAdapt, and the collaboration has been really helpful for us to improve our rigor, our statistical rigor within our CalAdapt tools. So one of the things that Owen's been working on is looking at compound climate events. So a lot of the data that we show on CalAdapt now is a single event, such as heat, precipitation, wildfire. But a lot of people are interested in multiple climate events. So things that are actually a combination of multiple variables. So for example, if you're interested in wildfire might be a combination of different climate variables, such as wind, precipitation, and heat. Something like mudslides, you may be familiar with the occurrence of mudslides that happen after there's been a big fire, and then it's hit with extreme precipitation. So again, those are compound climate events. Things like drought are a combination of precipitation and maximum temperature. Rain on snow events. So this is actually a big area of research in climate science right now. We're really just starting to look at how we can start to explore how these things might be projected to change in the future. So it's really an area of interesting research right now. And within CalAdapt, we have worked on a few different metrics that we have included within the local climate change snapshot tool. One of those is SPEI, the Standardized Precipitation Evapotranspiration Index. So this is a measure of drought that is using multiple variables. It's using both precipitation and then also potential evapotranspiration. And looking at those things together gives you this measure of projected drought. So this is something that's really commonly used for folks who are looking at drought. And again, we have added this into the local climate change snapshot tool, and it's also available as a layer that you can download through our data download tool. So again, one of our goals is always to make this information accessible for people to do their own research on. So we're really excited about the addition of this compound climate indicator. Another one that we've added into the snapshot tool is wildfire weather. This is an index called the Keach-Byram Drought Index, or KBDI. And this is a combination of both precipitation and maximum temperature. So again, we're looking at these compound climate impacts. And this is something that's used really often to, again, sort of project how many wildfire weather days may you expect to see in a certain location in the future. So this is something that we're also really excited to be beginning to explore, and also is available for users to download. If you want to start looking at this index in your own area or do additional research on it, you can get this data set through the data download tool. And there are within our local climate change snapshot tool, we've also added in other climate indicators, things like maximum one-day precipitation and a whole suite of other indicators that you can explore within the tool, and then also download the data for your own research purposes. So thanks to Owen for a lot of the great work on that. We also want to just briefly, let's see how much time we have left, just a few minutes, just a quick view of what's coming up. We're always working to improve CalAdapt. The thing that we're working on right now is a sea level rise and coastal flooding tool that's actually going to allow users to view multiple data sets portraying sea level rise impacts. So looking at CalFlood 3D and Cosmos data for extreme storm events. So that's coming. If anyone's interested in being a beta tester for that tool, please reach out to us. We would be really happy to have your input on that as it's being built. And as always, your feedback is really critical to us. We really want to listen to our users and potential users to improve our tools and make sure that what we're doing on CalAdapt is actually useful for you and your adaptation planning. So with that, I really would love to open it up to any questions that folks might have. Anything in the chat that we have not addressed, feel free to raise your hand and we can unmute if you have any questions or comments on anything that you've seen today. So please let us know. So we have a question from Zach. I'll let you unmute.
Hi, I'm a sustainability planner at Rincon, and I work on a lot of vulnerability assessments. And I was wondering if you guys had a recommendation on how to work with the precipitation data. I find that between producing the CalAdapt graphics and communicating it to a client, I often run into an issue where the averages don't change that much, and they have a hard time understanding based on the visuals that it's getting extreme on both ends of the spectrum and not necessarily shifting the average that much. I know that's not a very direct question, but I was wondering if you guys were working on something to change the graphic or if you had recommendations.
Yeah, that's a great question. I'll do my best to answer it. There may be others who can do even a better job, but I will say, it is true, what the research has shown is that precipitation in California is going to continue to be variable, as it always has been. So I think, it's hard for users. It's really clear to see that trend that we see in temperature, but there isn't as clear a trend in precipitation. And that's just what the data shows. The data shows that it's still going to be variable. But there are, the research is also showing that we might be getting more of that precipitation in extreme events. So extreme storms. and also that precipitation is going to be falling, at different times of year. So we have several tools on CalAdapt that allow you to really dig into that precipitation a little bit more. We have an extreme precipitation tool. I don't know if you ever had a chance to look at that. The extreme precip tool is really looking at how, how these extreme storms may change over time. And as I mentioned, within our local climate change snapshot tool, we've also added additional indicators, such as that maximum one-day precipitation event. So those are some ways to get at some of that more subtle information of changing precipitation patterns. But I think, it is challenging to when you look at that graph that just has a lot of squiggly lines, it is challenging to explain that to people. So yeah, we do have a few other tools that allow you to look at those extreme storm events. And if anyone else on the call has wants to add something to that, happy to let someone else speak to. Does that sort of help, Zach?
Yeah, I understand all the tools pretty well, I'd say. I think maybe this might be a longer conversation. I don't want to take up everyone else's time, but I do have some ideas for changing the actual graphical representation. And so I think standardizing everything is great, but at least for this, I think it could be done a little different. And so maybe I'll just either send an email or stay online.
Great. Yeah, we would be happy to hear your ideas about how to visualize that information differently. So that would be great. Yeah, and you can always email us at support@CalAdapt. So yeah, be happy to talk more about
Wonderful.
it. Yep.
Thank you.
Any other questions? Questions for Andy? And of course, feel free to enter them in chat. I do see that Tom Phillips has asked about heat stress metrics such as WBGT. Tom, I'm not familiar with what that index is, so it's hard to say offhand. We did just go through some of the new indices that we've added on Drought. I think if that index, if the inputs are variables that we have on CalAdapt, that's something that you could produce those yourself using the CalAdapt data. Precipitation, temperature, evapotranspiration, whatever those inputs are. So hopefully that we'd also be happy to follow up with you if you have any more specific questions about that.
Hi, Nancy, can you hear me?
Yes.
Yeah, I think in past CalAdapt workshops and input and so on, I think the main problem is that we need hourly data to do modeling of buildings. And I don't think you have that yet, right?
Correct.
Okay.
But I can answer, well, we have hourly data at those station locations. I know I briefly talked about that when I was looking at the extreme weather tool. That again is historical observed data at those station locations. So it's not projections. But I will say with this, our data on CalAdapt is part of the 4th climate change assessment. There is new downscale data being worked on for the state of California that's using CMIP 6 data under the upcoming California 5th climate change assessment. And that is actually including hourly data and at least sub-daily. So that information is coming.
Okay.
And that, yeah.
Okay. And I'll try to answer your question about WVGT. I always have to double check, but it's basically wet bulb,
right.
And a radiant temperature from a black ball or whatever in the instrument. And then I can't remember if wind speed is included or not. But anyway, and we did a paper on that a while back to apply it to indoor conditions. So I'll send that.
Okay, Great. Yeah, and we'd be happy to follow up with you if there's any way we can help you to, use the data on CalAdapt to create that. So
Okay,
happy
and
to
also
follow up.
the hourly data folks, some contacts for that would be good too.
Okay. As I mentioned, that is being developed right now. I know that the Scripps team is funded to do the CMIP 6 LOCA downscaling for the state of California. And that data should actually be finished sometime in March of next year, and then will be made available through our partner project, the CalAdapt Analytics Engine. So I'm happy to follow up again with some of that information. So
Okay,
that new downscale data should be coming within a few months. So,
Great.
great. And one final comment that I have is we would love to have you stay engaged. Again, we really value the feedback from our users and happy to work with you. One thing you can do is subscribe to our newsletter. We also try to have, describe our new data and tools on our blog posts, so you can check those out. And we also have all of our webinars, we record and post them on the website. So if you're interested in any of our previous webinars, you can always check those out. And of course, always please feel free to reach out directly to us. You can reach out directly to me at anythomas@berkeley.edu or to our support team. We're always happy to answer your questions and help you get the climate data that you need for your work. So with that, we're a little bit over, so I'm going to let everybody go. Thank you again. We really appreciate your time, and please feel free to reach out. And I will stop the recording. Thank you.